Let's do a beautiful sum. It is a very interesting one which you're going to do. Let's see the sum. It says that triangle MNT is similar to triangle QRS. So we require two triangles which are similar. So when we say similar, that means they are of the same shape but not of the same size. Length of the altitude drawn from point T is 5 and the length of the altitude drawn from point S is 9. So we know the altitude here is bigger, the altitude here is smaller. That is why this is a smaller triangle, this is a bigger triangle. And one thing you would say, whenever generally we draw triangle MNT, we start from here M, N, T, right? Now why did we take T here is, we wanted to draw the altitude from T. So it is better keep T as a vertical point. That is why we kept that. So if T is a vertical point then its corresponding point there, S should be kept as there, right? Is that clear? That's the reason. Now they say that length of the altitude from point T. So from point T there's an altitude and the length of that is given as 5. There's a altitude from S and the length of that altitude is given as 9. And they ask us a very simple question. Find the ratio of area of triangle MNT upon area of triangle QRS. Now let's understand this. We know that these two triangles are similar. That's given to us. And we are saying if triangles are similar and we are talking about area ratio, that means we know we are going to use a theorem, that is theorem on areas of similar triangle. And as per that theorem, area upon area is going to be side square upon side square. Now which one to take? It could be any of this, right? Let's take TM, so its corresponding is QS, right? So we want TM square upon SQ square. Understand that. So we will get this ratio provided we get TM square upon SQ square. But Tm square upon SQ square, right, we can solve provided we know what is Tm upon SQ. That means we want the ratio of Tm and SQ, right? How do we get that? We don't have any information based on that. But listen, now what is given to us is TA and SB is given. And what we need to find is Tm and SQ, right? If you look at this two forms a triangle. This two forms a triangle. So that means we'll get the value of Tm and SQ provided we have some relation between this triangle TMA and this triangle SQB. That's the interesting fact. Well, right now, can we prove these two triangles similar? We have only one pair of angle. Can we have one more? Actually, we can use it from the information which is given. We know one thing, that at the start we have been given triangle MNT is similar to triangle QRS. Now both the triangles, these triangles are similar. If they are similar, that means their corresponding angles are congruent. That means can I take this angle Q and this angle M to be congruent? Yes, we can take those two angles to be congruent, right? So write that angle M is congruent to angle Q. That is what we wrote there, right? And that's our result number 1. Let's use this for these two triangles as I said. Look here now. Consider this triangle. Now observe this triangle. So triangle TAM and triangle SBQ. If we consider this two triangle, in this two triangle we can say that angle M is congruent to angle Q. From where did we get that? From 1. And one more pair of angle, that is angle TAM congruent to angle SBQ. Why? Each is 90 degree, right? So that means now we can say yes, both the triangles, they are similar and they are similar to each other by a test of similarity. Wasn't that easy? Now remember, why are we doing all this? We are proving this similar so that we end up getting the value of Tm upon SQ. Now since these two triangles are similar, we can take the ratio of the corresponding sides. So now let's take the ratio which you want. So we are going to take Tm upon SQ. That will be equal to the two other ratios. Take the one about which we have information. We have information about TA, so we'll write it is equal to TA upon SB. Beautiful. So we write that. So now we write Tm upon SQ is equal to TA upon SB. Wasn't that easy? And the reason there is CSST, corresponding sides of similar triangles. Simple, right? But we want Tm upon SQ. We know what's the value of TA. What's the value of TA? TA is 5. The value of SB we know is 9. So we write that Tm upon SQ is equal to 5 upon 9. And we got that value. That's what we wanted. Now once we get this value, can we now apply theorem on areas of similar triangles? Yes, we can. So let's write the step. So now we'll write these two triangles MNT and QRS. They are similar, given. So if they are similar, we can write area of triangle MNT upon area of triangle QRS is equal to Tm square upon SQ square, as we discussed at the start. And the reason is theorem on areas of similar triangles. Now substitute the value, right? Area of triangle MNT upon area of triangle QRS, we don't know, keep it as it is, right? Tm square upon SQ square, directly we can't substitute the value of Tm. Tm is not 5, SQ is not 9, but we know Tm upon SQ is 5 upon 9. So can we write this in the form of ratio square? Yes. Tm square upon SQ square means Tm upon SQ the whole square. That means it is nothing but 5 upon 9 the whole square. That is what we are writing here. 5 upon 9 the whole square, right? Now we solve it further. Now 5 square is how much? 5 square we know is 25. 9 square we know is 81. So we write the next step. Area of triangle MNT upon area of triangle QRS is equal to 25 upon 81. And that's the value of the ratio which they were asking. So we got area of triangle MNT upon area of triangle QRS is 25 upon 81. Simple, beautiful sum, very important.